Hey, we're going to walk through a problem here. It says rotate the region contained by y equals 3x, y equals 0, and x equals 2. And we're going to rotate that around the line x equals 4 and calculate the volume of the figure created. So I'm going to do this using both washer first, and then I'm going to use shell afterwards. So I've already graphed the region. Makes a little triangular region in the first quadrant. So using washer and going around something parallel to the y-axis, which x equals 4 is parallel to the y-axis, I need everything in terms of y. So everything I put in my integral is going to be in terms of y. So remember the washer method. If there's a gap, which there is, between the line of rotation and the actual figure, is pi times the integral of the outer radius squared minus the inner radius squared. So let's see here. We'll have pi, and in terms of y, the integral will run from 0 to 6 over here. Excuse me. This might help. From 0 to 6. And then the outer radius will be from the line of rotation x equals 4 all the way out to y equals 3x. Now that distance is at most 4 all the way out, because we're at x equals 4. But we're going to take away that line y equals 3x, but we need it in terms of y. So I changed y equals 3x to x equals 1/3 y. So 4 minus the 1/3 y gets rid of the little outside part here. So the outer radius from my line of rotation to the edge of the figure is 4 minus 1/3 y. My inner radius is consistent all the way up and down. We're bounding this thing by x equals 2, and we're rotating it around x equals 4. So that inner radius is always 2. So with that in mind, my integration will look like pi and the integral from 0 to 6 of the outer radius of 4 minus 1/3 y squared minus the inner radius of 2 squared dy. Now I'll multiply all that out and collect like terms, and I will get pi from 0 to 6 integration of 12 minus 8/3 y plus 1/3 y squared dy. So when I integrate that, I'll have pi times the quantity of 12y minus 4/3 y squared plus 1/27 y cubed from 0 to 6. When I plug in the 6, I'll get 32 pi. And when I plug in the 0, I get 0. So my result is 32 pi. Okay? Now let's do the same thing using the shell method. So keep in mind when we use the shell method around x equals 4, which is parallel to the y-axis, shell method around the y-axis is in terms of x, so that's the same thing I'll do for x equals 4. So I've got the figure drawn out, and the shell method is 2 pi times the integral of the radius times the height. So as far as my figure is drawn, the little triangle region in the first quadrant, the x values run from 0 to 2. That's my A and my B. My radius will be from the line of rotation over here at x equals 4 back to whatever the line is. So that'll be 4 minus an x value. So 4 minus x, whatever the x might be. And then the height will be the height of the function, which the top height is 3x and the bottom height would be 0. So the height would just be 3x. So putting that all together, I get 2 pi times the integral from 0 to 2 of a radius of 4 minus x times a height of 3x dx. Multiply that out. I get 2 pi times the integral from 0 to 2 of 12x minus 3x squared dx. And then if I actually integrate that, I get 2 pi times the quantity of 6x squared minus x cubed from 0 to 2. If I plug the 2 in, it looks like I get 32 pi. I'm going to plug 0 in, I got 0. So once again, the volume is 32 pi. So whether I use the washer or the shell, I should get the same thing. I just want you to get comfortable looking at both. All right, good stuff.